Welcome to Fixed Wing Talk. I'm Steve Schlesinger. I am here today in quarantine, far away in Southern California, talking to my good friend, Mr. Mark Hoffman, live in Germany. Mark, what's going on?
Yeah, hi Steve. Still in quarantine here, lockdown everywhere, but yeah, we try to continue living.
So yeah, we're doing this whole quarantine thing. We're trying to keep at least one country apart. And so we have another friend in another country, Mr. Darren Lyons. Darren, what's going on, babes?
Hey Steve, yeah, I'm doing great. I'm actually enjoying the quarantine. Lots of plane building going on, so it's brilliant.
It's fantastic. Yeah, it's me too. I've just been spending my time building planes, and about every couple of weeks we get together and talk. And I guess we don't have a guest today, so it'll just be the three of us. Wait, we do have a guest. The guy who made this all possible, and I do mean made this all possible. The reason why everyone's tuned in today is Mr. Paweł. What's your last name? Spychalski?
Spychalski. It's Spychalski, and actually nobody from outside from the Poland is able to pronounce this correctly. So I'm used to hearing the most often the German version, and I accept it as if you say something like Spychalski, then it's fine.
Okay, and well, you're not social distancing super well because you're also in Germany, even though you're from Poland.
No, this is also not that simple because I am in Poland right now.
You're in Poland right now?
Yes, I'm in Poland. I left my German colleagues in Germany and I went to my motherland for the social distancing and quarantine part of this year.
Oh, fantastic. Fantastic. All right, so I guess we're doing the job properly. So we have us in all these different countries, and so we're going to talk to you today, Paul, about INAV, and I'm going to hand it over to Darren for first question. Darren? I don't think Darren can hear me. All right, first question. We want to find out about your background, Paul. What is your coding experience, and where did you get educated, and all that good stuff?
Coding experience probably started something around 1986, something like that. Well, I got my first PC. Not the PC. Back then I had what it was. Timex 2048, really like the super ancient stuff, and somehow the programming became one of the most important part of my life. Then we have high school, and I finished officially I have a title of I'm a Master of Computer Science and Engineering degree. This is how you're gonna translate it. And I'm working as a professional software developer for the last 20 years. Yeah, something like that. Different areas, started with web development, then more web development, and a few years back I switched to Java, and this is what I do now. And of course, during the evenings, I also code different stuff, like for example, INAV.
So you have a master's degree in computer science and code development, or wow, okay.
No, not the code development, because I have no idea why. My major was computer graphics. Don't ask me why it's computer graphics, why the whole my professional career I'm doing the software development, but this is what my diploma says. But yeah, I do have the Master of Computer Science.
So we could talk about actions in Photoshop then for most of the show.
No, rather not. Back then I was kind of interested in the 3D graphics. So yeah, maybe I will try the 3D graphics. But right after I've got my diploma, I actually stopped doing almost anything with the computer graphics. Got different things to do.
Okay. Hey, Darren, can you hear us okay?
Yeah. Can you hear me now?
Yeah, I hear you.
Yes. Now it's much better.
So next question, Darren.
All right, sorry. But so moving on from the coding, when did you first start getting interested in RC?
Something like 5 years ago. Maybe 5.5. This was back then when the first affordable and cheap drones started to hit the market. It was like, whoa, it's super cool, I have to get me one. So I got me one of those super cheap thingies. I think I still have it somewhere hidden. But then kind of quickly I discovered that this is not enough, so I got another drone, then FPV, or maybe I can build me an aeroplane. It turned out that I started to like building aeroplanes, and then somehow at one day I discovered that, well, those flight controllers are also something that you can program with the language I probably know. So, and now I'm doing everything.
So to take you to the flight controllers, I've been trying to follow the development of the flight controllers. They were originally, I think the idea was that they were supposed to be, about 2014, ARM in England was looking like they started figuring out we're going to have enough smartphones around the world where we're going to run out and we have to start thinking of other things to sell. So they came up with this idea of Internet of Things. And then they came up with something called a microcontroller, which was kind of based off the whole ARM technology. They're supposed to be like little 8-bit controllers at first, and then from that they kind of morphed into 32-bit controllers, and they were used in television sets. And that's pretty much for smart TVs. That's what most of these are used for, if I'm not mistaken, right?
Actually, this is kind of slightly older stuff, because the flight controllers that we are using right now, the grandfathers of the flight controllers actually started around 2011. I don't really remember exact date, but the first flight controllers called the Multi-Wii, from the family Multi-Wii, were based on the Arduinos and the gyroscope taken from the Nintendo Wii nunchucks. So really like 100% super hacky stuff. So this is kind of older. I'm trying to find exact date when the Multi-Wii was created. But if we are talking about the current flow of the changes inside of the derivatives of the Multi-Wii, because after Multi-Wii there was a base flight, then we had the clean flight diverged into beta flight and to INAV and so on and so on. This started more or less around 2014. Yes, this is more or less the date.
Okay. Now that's the big question. Now when we're talking about INAV, as I understand, this is your baby. This was originally
No, this is not my baby.
Not your baby?
No. No, the INAV was started by a guy named Konstantin, aka Digital Entity, and he is the maintainer, the owner, and the guy that really stands behind INAV. I'm just a bloke that's spending some time helping to develop INAV because I like it. I like development. I like flying, and I'm just combining two hobbies into one, and it's super cool. Plus, it's somehow right now the part of my life because, yeah, you know how it goes. But no, I cannot say that this is mine. I'm only just the front. If I really would have to. Someone would have to assign me a role. You might call me a front end because I have the biggest media reach of all the colleagues inside of the INAV. But I'm not the one that deciding about the stuff, the stuff.
Huh. Interesting. So you kind of jumped over a lot of things there. The idea was that originally that the first flight controllers were based off of the Nintendo Wii, the chucks that you use. Remember that game?
Yep.
The game controller, and they took the gyroscopes out of there and they used those into like multi-rotors, the first generation of multi-rotors.
Yes.
And they used Clean Flight. That was the first open source.
No. This is even older. The first one was from this family. It was the Multi-Wii, which was really Arduino plus the MPU 6050 taken from the Multi-Wii nunchuck, because that was the cheapest source of the gyroscopes back then. But even back then, the hardware was not powerful enough for everything what the guys wanted to do. And there was a guy called the Trollcop or the Timmy, I'd really always forget the name of the guy, and he decided to rewrite Multi-Wii on the STM32 platform. And this is how the base flight started. Unfortunately, there was a very serious problem, and the problem was that the maintainer of the base flight project was the 100% absolute douchebag.
Oh, jeez.
If one day you will be bored, try to search on the internet about the history behind the base flight and Troll Cop or the other nicknames the guy was going by. Incredible, really 100% incredible stories. And then one of the developers was the Dominic Clifton, aka Hydra, which right now is everybody thinks that he's the guy behind all of that. But Troll Cop and the Hydra had some. They were not able to really work 100% together. One forked the base flight and called it a clean flight, and then it's more or less the story that most of the people are familiar with.
Okay, so then we kind of get the whole idea now that it was just how the evolution started. But then I guess
the
what
evolution
happened
started because one guy was a douchebag.
That's great. Motivation there.
Yes, exactly. Yes. Not
So
the first one, not the last one, douchebag in the hobby.
So you had clean flight, and that evolved into beta flight. And from that, this is around the time that you got into, I guess, beta flight had problems with the GPS, and that was how the whole INAV development worked out.
INAV has not originated from the beta flight. This is another misunderstanding.
Yeah.
More or less in the same time, there was another slightly, let's say, conflictish element inside of the Clean Flight project, because the Clean Flight project was not very interested, in faster development cycle that the Boris B, the guy that everybody connects with the beta flight, and the digital entity who wanted to bring more GPS assisted functions into the Clean Flight. And after their pull requests were just sitting there for nobody knows how long, because the maintainer does not want to merge them back, they said, okay, independently, this is also very important, independently, okay, we are forking the Clean Flight and we are starting our own projects. So INAV and beta flight originated from the Clean Flight, although a year or maybe slightly longer, the Clean Flight resetted to the beta flight. The Clean Flight abandoned its own changes after the beta flight was cut and resetted to the beta flight. So Clean Flight actually is a beta flight with the custom logo, and that's all. But besides that, Clean Flight is dead. Long time.
Huh, interesting. And then, but it was from this that the issue was that there was an issue with GPSs. That's how I understood. There's something to do with GPS, and that INAV wanted to get more involved with the GPS.
Yes, that's the general idea. The digital entity wanted to bring the GPS capabilities known, for example, from the multi-wii into the Clean Flight world running on the STM32 CPUs.
Okay, you keep mentioning the STM32s. That's ST microcontrollers. That was the whole. Yeah, that is the micro. Those are the microcontrollers. When people start talking about F405, 722.
Those are different families of the same architecture. They differ in different actually in many areas, but they are just next generations of the one family of the microcontrollers.
Right. So the idea of these microcontrollers is that every time you see the F and then the number F405, F411, whatever it is, those are STM microcontrollers. And if you look them up, it's like, I guess it's STM F405 32 or STM32.
STM35 F405, and then there is a lot of digits that, for example, describe type of the package or exact amount of flash memory. But the most important is F or G or H, because those things are also coming, and the three next numbers, which is the major information about hardware capabilities of the hardware.
Okay, so you just touched on something very important there with those letters G, F, G, and H. And so what, and that's what's coming. So what is that? Because part of what we're trying to figure out is what's next. How much more capacity can these flight controllers have?
A lot. If it all depends what you really want to put into the flight controller. If, for example, you will drift into the autopilot world, but the autopilot is with us from even longer than the multi-wii probably. They have the most functions for airplanes, navigation, rovers, submarines, boats, and also big multi-rotors doing amazing stuff autonomously. And they, for example, the code is so big that, for example, they cannot fit the code into the probably the right now almost the most popular STM32 F722 because not enough flash memory on the F722. But there's still plenty of flash memory on the 405 or, for example, F765 or F745 or the upcoming and still not upcoming. The next big thing, which will be the H7.
Oh, that's right, the H7. That's a big one. And why is that big?
The H7 is the fastest family right now of the STM microcontrollers. They are the best. They are the best, the biggest, the baddest. They can decode MPEG-4. They can play YouTube for you. Of course, if you connect correct parts and elements to them, they are really the most powerful in every aspect. Although it's also interesting that the only H7s that currently are used on the flight controllers are the weakest H7s, the H750, which are really like weaker, to be honest, in terms of memory and the flash from F405.
Darren, you have a question?
I was just going, I mean, it's probably a step back, but I was just wondering what language is INAV actually coded in? You mentioned
it's C. It's C.
It's C. Okay, cool.
Yeah. Not even C++. It's C.
Wow.
Yeah. I have a question at this point because you were talking about autopilot. What I'm wondering is INAV has everything on the same code base. So we have wings, we have copters, we have soon rovers, everything in one image, and you just change the options depending what you want to fly. So autopilot has different images depending what you want to do. You have a special firmware for submarines, special firmware for rovers, for copters, for planes, and so on. So has autopilot really such a big feature set, so much more than INAV that they need that space even when they separate the firmwares, or is it just not enough cleaned up?
To be honest, I have no idea. To be honest, I have no idea why they decided into something like that. I just know that they do not fit on the F722s. Because to be honest, I'm not using autopilot almost at all, and I never really dug into what they have under the hood, how the project is structured. That was not really ever my interest, so I cannot answer this question.
Okay, so I have just one copter with autopilot because I needed some advanced navigation features, advanced waypoint features, and ground station software. But yeah, I would still prefer INAV because it's much easier to set up.
Everybody who saw how the configurator for the autopilot looks like, yeah. You know how it looks. You know how it looks. You know how it works, and yeah, it's a
nightmare.
Not the simplest software ever to be used by anybody to do anything, especially without like deep down understanding of how flight controllers are working.
Yeah,
yeah. The looks of that mission control, it sort of lends itself to it could be using up space because of clutter on the flight controllers. It's a mess. It's a horrible interface. And people's argument are, we want all this stuff here because it's so powerful, but that's not really an excuse for not having a clean UI. It's just, mess. But anyway.
The funny thing is a lot of commercial drones are based on autopilot, actually. Like Parrot, the Parrot Disco, and some other Parrot drones, their firmware code base is based on autopilot actually. But then the company does all the configuration, all the tuning, so the user can just buy the drone and fly it.
Yeah.
Hey, speaking of code base, one of the things that people are going to have questions about is that if some people have the F3 flight controllers, and then you said after 2.1 we're no longer supporting the F3 flight controller. Is there a flight controller that is in jeopardy of being discontinued that's out right now that INAV supports?
Omnibus. That's the shortest answer I can give you. Omnibus F3. Almost every F3 flight controller that has OSD, because the OSD code takes enough RAM that we cannot actually add any new features into F3s. Currently, all the F3s are only, let's say, maintained. If we are developing a new feature, like for example, I'm working on the, how it's called, the global variables and the logical conditions or something like that, we have to disable those features on the F3s because F3s does not have enough RAM memory and the flash memory to actually put it there. So probably the only F3 that has a chance of being with us for slightly longer is the original SP Racing F3, because it doesn't have OSD and it has some more free space to maybe put something else into it. But all the F3s are currently at least deprecated piece of hardware, and people should start migrating away from the F3s. By the way, Betaflight already is not building for F3s at all. We are still building, but it's more like maintenance of the flight controllers, not really like adding new functionalities to them.
Okay, interesting. What about the F411s? Is there enough? That's kind of one of the less expensive.
It's not that we have to disable anything for them yet. So they are probably just fine for some time. They are slower, but then you do not really need a lot of computational power for flying wings or airplanes in general, and they are usually for the airplanes. I would not be worried about them going away in the next at least few years. They should stay. Although, but they are fine. Let's say they are fine.
That's good to hear. Fantastic. One of the questions I had for you was, absolutely lost my mind. Mark has a question for you. I think I have to remember it.
No, I have no question right now.
Okay.
I'll stick a question in.
Oh, yes.
Okay, so away from INAV for a bit, what are your favorite things to fly in general?
In general, if we divide it into categories, category number one is the airplane. It's my mini truck, definitely my favorite airplane out there. But if I would have to say which one I like more, multi-rotor drones or the airplanes, I cannot answer. I definitely fly more of the multi-rotors because it's simpler. You don't need so much space and it's like slightly more convenient. 7 inches. I think the 7-inch multi-rotors are my favorite. Yeah, probably my favorite one.
That was the question I was going to ask you. Why did INAV migrate towards fixed wing when Betaflight stayed away from it?
No, we haven't migrated to fixed wings.
Well, I mean, like you added the working for fixed wing.
It's because none of the flight controllers running back then on the STM32, at least now the open source one, were really supporting fixed wings. That was the reason. That was the chance to get some of the market. That probably there will be a lot of users if we have a code that's usable on the fixed wingers. However, with the Betaflight always was about 5 inches. Always. 5-inch multi-rotor is the target hardware for the Betaflight. And they are evolving around the 5 inches. Yeah, of course, from now we have quite popular 7s, we have 3 inches, but still the 5-inch multi-rotor is the core hardware on which the Betaflight is running, and the developers of the Betaflight were never really interested into adding anything else because they are very specifically mainly for the 5 inches. They just never thought that's a good idea, and that's why if anybody flies fixed wing, then probably it's INAV, as long as it's running the same hardware as Betaflight.
So when it comes to size and fixed wing, I was listening to you talk yesterday, and you're talking about how somewhere between 900 millimeters to a meter is about the perfect size for INAV.
Not for INAV, for me.
For you, okay.
For me, yeah.
Okay, because we
like
have like different things going on right now as far as when I'm watching the group. We have people like Mark Hoffman here, who are in love with his little Dart 250G, and so he wants something as small as possible to fly. And then we got guys who want to put INAV on 2.5 meter wings, and so we're trying to figure out, is there an ideal spot for INAV to fly that out of the box works great?
No, actually not. With the aeroplanes, it's much simpler. It's much simpler to have something like a generic settings because aeroplanes are stable by the design. They are stable. If the aeroplane is not aerodynamically stable, it falls down from the sky no matter what. You cannot really stabilize a not stable fixed wing. If you have center of gravity move too much backward, it will fall. No matter what you're gonna do, it will fall or just fly horribly. So everyone who knows anything about the aeroplanes at least knows how to set up the center of gravity. And only setting a center of gravity is such a huge help for the controller to stabilize it that you can actually have one, let's say, almost universal settings for the fixed wingers. This is absolutely not correct with the multi-rotors. Multi-rotors are unstable by design. If not actively stabilized, they fall off the sky. And because of the huge differences of the not only thrust to weight, because thrust to weight is a factor that actually does not really matter. Something that people are not talking because probably it's too complex is the thrust to inertia rate. Because the inertia, the bigger the multi-rotor is getting, the inertia is growing exponentially almost. And it's so hard to... Okay, I think I'm lost. I think I drifted too much. What was the original question?
We're talking about size of fixed wing planes.
Yeah, so with the... As long as it flies, then INAV can fly it. That's the answer. Okay. Because it's so universal.
So one thing you brought up on there was people who fly fixed wing know about CG and all that, but in the group we see a lot of people coming over from multi-rotors, and they think they can fly a quad, so they think a plane's going to be easy or a wing's going to be easy, but it turns out not to be the case. So have you got any advice for people other than actually you need to learn about CG and all this sort of good stuff? And is there anything that in INAV they could do to assist them in that journey, or they just really need to get...
Setting up INAV for the fixed wing versus the multi-rotor is not that different. You set a mixer, you set up some modes, you maybe set up rates and OSD, and you are more or less ready to fly. But like I said, the airplane has to have at least correctly set up CG. If this is not done, then sorry, but the airplane will not fly correctly. And it's really hard to expect from the flight controller project to tell all the people how the CG, for example, should be set up on their airplane. This is not the responsibility of the flight controller over here. Just like with the multi-rotors, you have to know that the CG should be somewhere between the motors and it should work. This is how in the fixed wing world, the CG has to be slightly in front of the center of pressure and center of drag, those kind of stuff. But if you want to, there are really like plenty of pages in the videos in the internet telling you how to do it.
So one of the questions I have is, we get a lot of people come into the group, and we've actually from time to time, we've asked people to rate their favorite planes in the group. It always comes out the AR wing or the ready-made RC Recruit is the #1 fixed wing plane. Yet when you look at the mixer and models, the S800's on there, but the AR wing is not on there. Is it possible that we can, as a group, start thinking about coming up like with ideal mixes for the 10 most popular planes for INAV?
I know that Mark does not agree with me. But mixer, you should not touch the mixer. The mixer is for the type of the airplane, because you have to have a different mixer for the flying wing and a different mixer for the something traditional with the tail and the elevator and the rudder, because they are different number of servers, for example. And this is my opinion, of course. Mark might not agree with what I say, but I, for example, say that all the flying wings should have exactly one mixer. That's all. Because everything else you can modify with the PID controller, and everything else you can modify with the rates. There's no really need to have a specific mixers. But like I said, with the aeroplanes should fly even on the default PIFF settings. And then there is auto tune to tune the behavior of the at least feed forward, and it will be fine.
Yeah. So, by the way, we had a talk recently where we spoke about the mixer and how I can get more servo throw out of the plane without changing anything in the mixer. But your suggestions didn't work. So, in the rate screen, so pit tuning and then rates and other stuff, if I try to raise the manual rate, does not go above 100%. So I had no chance to get more aileron throw even in manual mode without raising the mixer a little bit.
50-50 is the default mixer you set up on the radio, for example, when you're flying without the flight controller.
Absolutely true. I think.
Yeah.
By the way, after I changed the servos in my AR wing to Emacs servos, the 50-50 mixer was totally fine. It was enough. So the Emacs servos had much more throw. So it just seems that some servos on the market, maybe for plug-and-play planes, really have much less throw in one direction. So the 50-50 mixer is just not enough.
This is possible.
Yeah.
This is possible. Because let's be honest, the plug-and-play are the cheapest crap out there. Those are the cheapest components you can get.
Not the Dart 250G. These servos are amazing.
Okay, if you say so.
That's the exception.
What I was just going to say is there are two things. On the outputs tab, I believe there's a weight in there that you can set to put the servos up, because I think I did it to 120% on mine. So that the outputs tab, it was the servo page back then, but you could adjust extra there.
The endpoints, yes.
Yeah.
And raise the endpoints.
But going back to the traditional, on a regular flying wing, yeah, it'd be 50-50. But if you've got a plank or a forward swept wing, it wouldn't be, because it's different. So like, I can't remember which way around it is, but a plank is more pitchy. So you'd have less throw on the elevator than you would the aileron. And then a forward swept.
If you fly with the stabilization of the at least rate mode, then actually this is taken care about by the PIFF controller, not by the mixer. And my mini drag is a forward swept wing, and I'm flying with the default 50-50 mixer. And it flies amazing.
It's amazing. Well, the thing that I'm most concerned about is we get people that come into the group who they come in from all over the world. And when I literally look up where they're at, some of these people are like living in farms in the middle of Denmark, and go out and find someone to help you get, started on a fixed wing plane coming out of a quad. They can't find anybody. So what I wanted to do with the group is start giving people real simple builds so that they could, for your first build, take it. I did my own experiment. I have a friend on the East Coast, and he's been flying fixed wing planes for 2 or 3 years now. But what I did was I told him about INAV the whole time. I literally set up an AR wing, and I set up the controller and everything. I sold him everything, sent it out to him, and he took it, started flying with it, and it flew beautifully. And he said something that was interesting, which is that he grew up playing video games. So the whole INAV experience was something that was very familiar to him. And that's kind of where we're looking at. I've listened to you talk, Paweł, before. You're talking about how RC flying itself is kind of like the market's getting smaller, if not going away. The people who flew in gas planes, the nitro planes, in the parks were from. They're older now, and the newer generation isn't really interested in going to the parks and flying it.
And probably if you will go to the park and fly something in the park, the people will not be super happy about that.
Yeah, right. So when you got to helicopters, and that's why drones were all of a sudden, it got people's attention. This is something you can take out of the box and you can start flying. And INAV has never been that experience where you take it out of the box. But if we get something where if you can give you the instructions, you can build this, and if you're by yourself, you can pretty much get it flying. That's kind of, I think, would be a lot more for it, and we could probably attract more people in. Especially, the interest is out there for INAV. I think it's just that whole part about the barrier to entry is kind of difficult to get into INAV and into fixed wings. And I'm trying to make it as simple as possible for people now.
Yeah, but what's exactly the question?
Well, the thing is like, what can we do to help people as far as giving them some simple, I came up with one for the air wing, a simple build. I gave them a formula, which is basically if you buy these parts, you put it together in this way, took photos and explained everything, over-explained everything. And at the very end, I gave them the diff file. So you put this together, and if you use our controller software that Darren designed, we can, you'll get something that will fly. What I'm looking at, what I can see as far as INAV is concerned, it seems to me that most of the interest that coming into INAV, what brings people into INAV, seems to be fixed wings more than multi-rotors right now. I might be mistaken about that, but that kind of.
No, you're not mistaken. This is correct.
Yeah.
We have more fixed wing users than the multi-rotors users.
Okay, so we're a growing segment of it, and we're getting a lot of people come in from who are loyal beta flight pilots, flying quads of beta flight, and they come in and the first thing they tell me is like, hey, this is really similar to beta flight. The setup is really similar. We just added the 3,000 member in a group this week, and the guy's talking about setting up PIDs and stuff like that, and on a dual, he had one of those planes that had 2 motors on it, and right away I felt like I was talking to Mark Hoffman. He was like a kid in Alabama or somewhere. He's about 20 years old, and he's just really sharp, and he's figuring this out. So that to me, I mean, at first I was thinking about we should attract as many multi-rotor people over to the fixed wings as possible, but now I'm thinking that there's just a whole segment of people who want to fly something. And we have had a couple people join the group who never flew anything, and they started off flying fixed wing.
I see a problem over here, and the problem is that the RC hobby is not the simplest hobby out there, and I'm kind of afraid that some of the people that are thinking that, oh, I will start flying something, have watched too much of DJI is doing. Because they take the DJI drone from the box, plug in the battery, plug in the controller, and this thing is flying. Unfortunately, this is not that simple with the RC hobby and the FPV, because not only you have to know how to steer this thing, you have to know that there are 2 sticks, and when you move the right stick to the right, it's gonna roll right if you are in mode 2, but if you are in mode 3, it's gonna do something completely different. You also actually have to know something about the basics of the aerodynamics. You have to know basics of the electricity and the basic radio knowledge, and really a lot of stuff that are not very popular among people. So I very often think that people think it's simple, it's easy because the DJI does it, or for example, they just flashed Betaflight and they are happy. But one more time, with the Betaflight, it's super simple because you get a drone, there's only one way to build it, you plug in, you flash it, and you fly it, because it's only 5-incher. with the fixed wings, and the number of possible designs is huge. It's really like you can get whatever you want. 1 motor, 2 motor, 3 motors, motors in the front, motors in the back, motors on the tower, EDF, and you can have back swept wings, forward swept wings, you can have flying wing, traditional. It's more without knowing at least the basics of at least aerodynamics. Yes, Mark?
Yeah, I think that's a big problem. So I'm also a little bit concerned giving people too much build plans for like ready to fly or plug and play planes. I know that's what's your target, Steve. And if we give the people these planes, they solder everything together after the diagrams we give them. They put a diff in there. They use Darren's setup. Yes, these planes will fly great if they are able to handle that. That's everything fine, no problem. But as soon as they want to build their own plane, they don't know what they did. I think that's a problem. There is the learning point is missing here.
I knew you were going to say that, and so that was one of the things I was going to, why I came up with the whole thing, which was what I've seen is I've seen a number of people who've attempted to come to the group and they attempt, and there is a barrier of entry to get a plane flying, and so what happens is that barrier is this high. Sometimes people put out this much effort and they don't quite get to over the top. And then after a while, it kind of sits in the corner and they go away. So my thinking was, this is not going to be easy. You're going to have to solder a flight controller. You might not have a soldering iron. You might have never soldered anything in your life before. You have to follow these diagrams. But at least when you get stuck, we'll know exactly what you're talking about because we know where you're coming from. If you can get over this threshold, and then you get the experience, you go out and fly it, and if you like it, then you might be more interested in going back and learning how to do the rest of it. You know, it's like one of the things that my build, or the build I did, was all the units are imperial, and if you're not living in the United States, you probably want it in metric. So right away, you have to know how to go back in and figure out how to change that. Otherwise, you'll be flying in feet and have no idea what the hell how high up you are. So that's kind of things.
Divide by 3.
So I wanted something where it was like, hey, this is something this is the most popular plane. If you build this, you can follow the directions, you can get it flying, and then right away, I mean, the guy that I sold the plane to right away was talking about 3 more planes he wants to build, and so I'm like, the next one's on you, and I'll be here to answer the questions. I can help you out, but you're gonna have to learn this stuff. So that's interesting. I know it's something that we're doing. We're experimenting with. Maybe in 6 months from now, we'll have a bunch of people are pissed off because they crashed the planes because they couldn't quite build it right, and then we'll tear that whole thing down and we'll move on from there. But I'm just trying to see what I've noticed in the group is that people, once they get started in the group, and once they get the first plane, before long, they're on the third plane. It's just like, it's something that about INAV, I don't know what it is. Once you get that first plane built, and once you send it out flying, once you hit that return to home, and you see that plane coming back to you, you're a believer.
Yeah. I think that's absolutely true, but I also think that you cannot get everybody in the air. So some people just will give up. Some people just can't understand how it works. And I think that's just part of the hobby.
At that point, you say, go get a parrot disco.
DJI Mavic.
The DJI Mavic. Yeah, I'd be really happy with that. Let's see. So what are the plans for future development now that we've got you here?
You have to understand something about the developers of INAV and how this thing is really working. We are not a team in a meaning that we together develop a feature. We are individuals that are interested in sharing our skills and our effort into building something that's called INAV. We develop stuff because this is very important. We are not paid. We are not paid for what we are doing. For all of us, this is our hobby that we are doing in the evening somewhere, hacking somewhere. Okay, I want something. We are developing stuff usually that we want for ourselves. When, for example, the fixed wing support was added to INAV by Konstantin, it was because Konstantin wanted to fly a flying wing or airplane. That's the reason. That's the story. He wanted to do it, so he implemented this. When, for example, I wanted to fly my 5 and 7-inch multi-rotors with INAV, I improved how the processing, how the filtering, how the PID controller is working, because I had an interest. Then the same story goes with the Rover. I want to be able to ride a Rover, drive a Rover with INAV, so I'm working on it. It's really depends on what the developers will be interested in. Besides, it's an open source project. That means anybody can go in and add code that does something. If we're gonna merge it or not, that's a completely different story, but anybody can do it. And usually those are people that are somehow interested in it. Sometimes, yes, sometimes someone is, let's say, paid to implement something for the INAV. It's happening from time to time because a company would like to bring a new product to the market, and for that, of course, they need support for something. But this is happening only when there is a sponsor for the functionality. And I'm not sure how aware are you of the prices among the developments, especially the guys who knows about flight controllers. We are not the cheapest one to hire. So there really has to be a sponsor that's interested in something to hire a developer to implement a feature because a company wants this feature added something. If there are no sponsors, then it's only a goodwill of all the developers that are somehow interested in implementing something. So I cannot really tell you what is the unified goal of the INAV, what will be added in the next releases. I know of what I'm working currently right now, and I know what my colleagues are working currently right now. Will this change? Will we abandon our work? Who knows? Maybe. I can tell you what will be in the 2.5. Yes, without any problems. But I cannot tell you anything about 2.6 or 3.0. No, absolutely idea. Because it all depends on what the developers will be interested in.
Okay, so looking to the future, is there anything that you're particularly interested in that might see it into future releases? And other than the global variables that you're working on at the moment, is there something that you've got planned for maybe 2.7?
The global variables and the global functions and improved logic conditions. This was something I was actually interested in because I thought, oh, it's super interesting. I'm gonna write a PLC controller into the INAV. So I did that. And this stuff will be released with INAV 2.5. So the possibilities will grow. That's, for example, someone will be able to write his own, let's say, obstacle avoidance for the Rover. It probably will be doable with the framework I'm providing. So this is, for example, something that will be released in 2.5. I'm also always interested in better performance of the multi-rotor drones because I like to fly them and I don't like the fact that for some crap I have to install Betaflight for some in INAV. I just prefer to have one software running everything. And if I'm happy with how it flies, I'm not developing this. I'm also interested in Rover, so I'm implementing the Rover. What else? What next? Who knows? Actually, I have no bloody idea what else might be on my plate. It's also not very uncommon that a developer takes a break. I think I skipped at least 2 releases of INAV without doing almost any active development because I was not feeling like into it, and this is normal. If we do not want to develop something for INAV, we just do not develop something for INAV because this is not our job, this is our hobby.
I have a question at this point. So you're working on the Rover integration right now.
Yes.
And by the way, will this be released with 2.5 or just?
Yes.
But as a beta feature, I think.
I don't want to say beta. I have my Rover over here. So the hardware is definitely a beta.
Ah,
Looks
okay.
like a beta, right? It's not that with the INAV 2.5, the INAV will do everything that, for example, autopilot is able to do with the Rover. But what I can tell you, what will be possible with INAV 2.5, bidirectional mixer, bidirectional ESCs, so the Rover can forward and backwards. That's kind of needed, you might say, for the Rover. And the 3D handling of INAV 2.4 was completely broken, absolutely not working. So I had to rewrite this functionality to correctly handle the rotations, direction, speed of the ESCs. And this is also for probably the 3D pilots will be able to use INAV again, or finally. I had to change and what's working. Waypoints are working. You can send a rover on the waypoint mission. You just point on the map and set go, and it goes actually where it wants to go. It even performs a return to home. If you flip a switch, it will drive towards the place where you arm the rover. Of course, ignoring all the obstacles and just going like through them without like taking care of what's happening. And that's all.
Yeah,
this is what will be working with the INAV 2.5.
Yeah, sounds good. And this exactly leads me to the main question. If you plan to do rover missions or missions anyway, what about future waypoint mission or waypoint types like position hold or such stuff? So it would be nice for the rover too, like you are stopping then at a specific point, and then with your global functions or your the logic conditions, you can do a camera pan, a 360 or so, and then drive to the next point, such stuff. And
you're a smart guy, Mark.
And this would continue.
This is kind of independent from the global variables function and conditions. This is completely independent because this is completely different engine. And for the INAV 2.5, my colleagues, mainly Stronach and Giacomo, I think, I hope I haven't forgot about anyone, implemented jump for the waypoints, so you can program what will be happening between them, and something else, but I'm not really following that super closely. If anybody would like to check, there's always a GitHub merge request page when you can filter via the release. There will be improvements for the navigation engine, so more functions for the navigation engines on the waypoints. I'm planning to bring the integration of, for example, which waypoint is set up right now for the global variables and the functions and the logic conditions. I think I should, by the way, change the name of that because that's too long. I would have to figure out something better. There will be an integration, but still, those are, let's say, independent functionalities.
Okay, and what about the number of waypoints possible? Because right now we are limited to 60 waypoints. Is there any plan to raise that because the chips are more powerful?
It's only a number. Probably we cannot raise number on the F3s.
Yeah, of course. Forget about the F3s, but it's.
There will be a need to have more waypoints. We can just modify one define in the code, and if there is enough RAM and the RAM memory inside of the flight controller, the number can be higher. Of course, somebody has to say we need more. If nobody says we need more, we're not raising the number. This is okay. This is why, for example, the limit of servos, the servo number, was raised to 16 only recently, because there were no really flight controllers with more than 8 servo outputs until Matek F765 showed up. Before that, no flight controller that can handle more than 8 servos, so why to raise the number above 8?
Okay, so my and now we come to my last question at this point regarding waypoints. Smart return to home, especially for fixed wing planes. That would be really fantastic, especially if you are doing long range flying in the mountains or so.
How brave are you?
Pretty.
Okay.
If
you are really brave and you are willing to test, there is a branch for that.
Oh wow, that sounds good.
I told you so the block would work out.
No, Alberto worked on that like 2 or something years ago, and I know that he did something, but the code is currently probably very much outdated. And based on some black box analysis, yeah, it returned over. But I don't know. If you are really brave enough, then I can compile you a version with smart return to home. Are you willing to test it?
Yeah, do it. I will test it.
Okay, then
do it.
Send me your flight controller target via the email. I will try to build you a target. Maybe you will lose your plane, maybe not. Who knows?
Yeah, I have telemetry. I have the GPS information. It's all fine.
Yes, I can telemetry today as well. And what? And my flying wing decided to fly away on me today. I told you about this, Mark, before the chat. I luckily recovered that, but it took me like an hour to find it somewhere in the field. So it's not that simple, really.
Okay, so Steve, Darren?
Yeah, one of the questions I did have for you was, we get this from time to time. People ask us about the servos. There's digital servos versus analog servos. In INAV, does it really make that much of a difference?
No.
I didn't think so. No, it's just they work this.
No, this is mechanical stuff of how it's working internally. The driving of both of the servers is exactly the same with the same protocol, so it doesn't really make sense. But doesn't really make any difference from the flight controller point of view.
One of the features, I've never owned a DJI drone before, but one of the features that people talk about liking in the DJI drone was the ability for you to go fly somewhere, record it, and then play it back. So as a feature where you can
smart return to home. Yes, this is what something the Mark was saying. Yeah, there's a branch for that. If you are really brave enough, you can try it.
Okay, that's what we're talking. Okay. Oh, that'd be okay. Yeah, I'll be interested in that too. That'd be kind of cool. Well, one of the things I was wondering about was that the way that you set up the auto tune, which works really fantastic. And maybe we should take a minute, because I do have questions about auto tune and auto trim, and we get this from time to time in the group, and I should really go into this and ask you guys. We should hash this out once and for all. First of all, auto trim.
Yes.
The way that Mark wrote the manual said that what you're supposed to do is take your plane up to a certain level, put it in angle mode, turn on auto trim, don't touch it for about 5 seconds, and then you can start flying it, land it, disengage it, and then that will save it. So
almost perfect. Almost perfect explanation. I would only take out the angle mode. Just fly it without touching your stick for 10 seconds. That's all.
Just fly. Don't touch the stick for 10 seconds.
Don't touch the sticks using any of the stabilized mode. I'm personally a huge enemy of the angle flight mode. It's evil, and the horizon is even more evil than the angle, at least for me. So I never on the airplane, absolutely never do anything like that. They are stable by design. You can just fly every time in acro mode, because this is how airplanes without flight controllers are flight. And it's simple, relatively simple. So just take off, put a throttle on the cruise throttle that you will be using, put it on the level. By the time, it will take some time for the PIFF controller to set up the internals for keeping the level flight, flip the auto trim, land safe, and you are done. Nothing else.
So when I tried that the other day, I took my hands off of one of my planes, and what happened is it started to drift kind of to the right, so it was starting to turn. So I'm wondering if it's just that I don't have the it's not trimmed properly.
It might be that after the first auto trim, probably the trims will be better, and then, but by the way, then you can have this thing run again. It's not a problem. After the first trimming done, you can trim it again, and probably on the second run, the results will be better.
Okay, so this is fantastic. Leads me into my point. What do? You're brand new, you get a plane, and you're taking it off. You're in acro mode. You chuck it off. You start flying. First thing, auto trim or auto trim?
Auto trim.
Auto trim. Okay, that's what I always thought too.
Definitely auto trim.
Auto trim.
Yes.
Yeah. Okay, so
and
auto
then auto tune.
Okay, so auto trim, then go back and do an auto trim again.
You might, if you feel that something is still wrong. That you might do auto trim as many times you want. This is very simple procedure. If you're, for example, using different batteries or add something on the nose, and the balance is not really 100% exactly like the flight before, you can just do auto trim whenever you want. This is absolutely safe.
Perfect. Okay, now auto tune. So we've had people share all sorts of opinions on this, and you jump in here, Mark, and let me know if I'm saying this wrong. This is exactly how Mark has explained it in the manual, and which is in the group. It's if you go, we have links to it. It's he has this masterclass tuning manual. It's also an INAV's wiki as well. The idea is what you're supposed to do is put the plane in acro mode. First of all, take off in acro, you get it to a comfortable height. You turn on auto tune, and then the first thing you're supposed to do is you're supposed to start flipping the plane, make it do rolls and loops.
Start flying. No, just start flying. This is enough. You don't really have to make a loop, even one. But maybe you should at least once. But no, start flying. Do not fly in the straight lane. Just start flying. Gain altitude, lose altitude, bank to the left, bank to the right, and that's all. Because this is how autotune is working. It's comparing input with the output, and if the output is too small, it just raises the FF gains and adds slightly the I gains, and that's all. And to be able to do it, you have to really bank left, bank right, climb and dive, and you should be fine. And also, if you saved the tune once, you can repeat the tuning. That's really not a problem.
Yeah, Mark.
So yeah, I'm not sure if I made that clear in the manual. Maybe Pawe, you need to show me how I can update the manual for myself in the GitHub if needed. So usually on small planes, for the auto tune, you should fly the plane like you would fly it normally. So on an acrobatic plane like my Dart 250 or an ARing 600 or so, you can do full rolls, you can flips, you can do loops and all that stuff. And if you have a big plane, you just do bank angles. Of course, you should do banks and pitch up and pitch down with full stick deflection. So the flight controller finds its rate limit correctly, but that should be fine. So no rolls needed at all.
Oh no, you just fly like you would fly this aeroplane. And
how long should you do it for? Does it record after? Does it stop recording after a minute or two? You should do it for 5 minutes.
No, it's working as long as it's enabled.
Okay, so complete flight that is the ultimate way to do it.
Of course, probably it doesn't really make sense to record the whole flight like going 5 kilometers one direction without touching a stick, because you will not tune anything.
Right.
With that, but like few minutes.
Okay.
What I like
minute and two, and you will be fine.
Yeah.
Of actually doing in the air everything you would be doing with the airplane normally.
Yeah. What I like to do is I have a special tuning OSD set up on every plane. So I show my pits in the OSD, and then I see if it changes drastically on some maneuvers or if the changes are very small. If they are small, then I'm fine. Then I disable auto tune. The tune will stay even if it's disabled. Then I fly around. I look if I like how it flies. If I like it, then I land and save. If I don't like it, I do the auto tune again. Well, I continue with the tune.
Yes.
So the thing is, though, when I'm flying normally, I'm changing the throttle, and I guess in auto tuning, I'm supposed to change the throttle.
You might, but it's the best idea to leave the throttle on the cruise throttle. The throttle you will be using the most.
Not cruise model, but the throttle's position. If you normally fly at 40% throttle, keep it at 40% throttle. Then for the
yes.
Okay.
Somewhere in the middle, in the speed, so that the airplane has the speed that it's not very close to the stall speed.
What I recognize. Yeah, Darren.
Sorry,
go ahead.
I was just going to say, so if it is a plane that you do like to fly fast through the trees, lots of loops, lots of gaps, then that's how you should tune it. It's very much how you fly the plane.
Yes, exactly.
Yeah.
So I forgot what I wanted to say. Yeah, I forgot it. Okay, go ahead.
Excuse me, guys, for a second. I have to ask something. Okay, like 30 seconds.
Yeah. Okay, no problem.
Okay. We'll talk amongst ourselves here then. So
yeah, I was thinking. No, I really forgot what I wanted to say.
It was either about tuning or the Dart 250G.
Okay. It was relatively simple.
Hey, look what it is. Can you introduce your guest? We got a guest vlogger today. Say hello.
That's
Does she
my
speak English?
One. No, she doesn't speak English.
Okay.
My older daughter also does not really want to speak English yet. She's learning, but not yet. By the way, it took my teachers like so bloody long to teach me English. I'm anti-talent in terms of the multilingual. It's a nightmare for me.
So this, all right. So it seems like what we have right now, what I'm hearing from you, what we have right now in INAV for fixed wings is pretty much what we're going to keep for at least a couple of more versions of INAV.
Probably. There is really one thing that everybody would like to be fixed, and this is the horizon drift.
Right.
But so far, everything that we were doing was not really working. So.
Okay.
And we tried multiple times. We really tried multiple times, and there seems to be like very, very deep problem of how the things are running right now. So, although we tried, we were failing all the time.
So, what were you trying? Can you talk about
it? There was an attempt to use the compass for the computation. There was an attempt to use the same approach that autopilot was doing. There was an attempt to include the information about the centrifugal acceleration from the GPS. I tried to run everything through the Kalman filter because some say that Kalman filter will solve all your problems. And no, it doesn't, and definitely not in this case. And so far, nothing really worked like we wanted.
Huh. Well, something to work on in the future, I guess. But I mean, for right now, INAV is full featured, and it really is for fixed wing pilots. There's more than enough there to keep you happy for a very long time, which is the question is like you started mentioning before, all these different flight controllers coming out. Are we going to see any real advantages to adding these newer flight controllers to our planes?
No.
Okay.
There are not really any, at least from my point of view, any bottlenecks on the hardware right now. The modern hardware does everything that it's supposed to be doing. It has a lot of computational power. It has a lot of input outputs, and it has a lot of flash memory. At least the modern flight controllers to hold everything that might appear in the open source flight controllers for quite a long time.
Okay, Mark.
Yeah, we have a question in the chat that was already asked, I think 1 or 2 times before. Horizon drift in INAV. You made a fantastic video of it. I also already recommend what you say in the video with the IMU accelerometer ignore rate. Of course, make sure you have a clean build. You have no vibrations, or you have very low low pass filter set, so no high frequency vibrations go into the flight controller.
Yes.
But sometimes, especially on planes, the horizon drift is still imminent. I see it on my Dart 250G and also on my high-speed AR wing when I rip around. If I fly level and I just cruise around, it's totally fine. But as soon as I do acrobatic maneuvers and all that stuff, sometimes the horizon still gets vertical and all that stuff. So is there any plan for the future with some new code or something to...
I just answered this question. So far we tried everything we could and without any positive aspect. There is actually one thing I'm working on with brakes, and I actually tested this, but only on the multi-rotors, and it is the external inertial measurement unit connected via the I2C. That somehow does the magic better. I have it installed on the few of my builds. It's this board. You see, is the board visible over here? Yeah, it's the BNO 055 by Bosch. Good solid German company, Bosch. And this small board combines the accelerometer, the gyroscope, and the compass in one package, and is doing a very relatively advanced sensor fusion of all the three things. And so far, it's resistance for the artificial horizon drift, but only what I tested on the multi-rotors. There is no drift on the multi-rotors. However, it's external hardware.
Interesting.
Okay.
Speaking of external hardware, the thing that came out towards the end of last year, it was really hot. And then all of a sudden, I hadn't heard anything more from it. It was supposed to be the Pixel, the new OSD, Pixel OSD.
Yep.
So what's going on with that? This is the graphical OSD I'm talking about. Yeah.
It goes like that. I cannot answer the question, really. I cannot tell you how exactly it will be working and what exactly will be implemented, because this is one of those sponsored features.
Okay. Oh, so it's not secret.
This is a sponsored feature. This is a feature that was sponsored on the hardware and on the software level by the FrSky. And FrSky has all the rights for the hardware and the software running the graphical OSD. And if somebody feels like, okay, I will implement something brand new for the graphical OSD inside of the INAV or the Betaflight, then this person can do it. But if the FrSky will not sponsor any new major feature for this, what can I say? They are the ones that are getting money from this, right?
I haven't seen the demand. Well, I mean, when you think about it, they had Brain FPV came out with graphical OSD that works in INAV. It's pretty when you look at it. But this is something that's supposed to be over and above, or it's supposed to be really kind of cool looking if it were to work properly. But is that going to take up a lot of resources out of the flight controller to work it, though?
No, it's mainly the resources of the developers that will just work on it. Okay. And because I'm honestly, I don't care about this feature that much because I was not paid to develop it. That's simple. That's simple. Yes, that's simple. I know who was paid to develop it, and I really think that the guy made really a good deal out of this. And because the FrSky is the ones that are taking any money from the development of the thing, and because they are selling the hardware, they are the direction in which the money flows from the users. And why should I for free help INAV to run a business?
Yeah, I hear you. The other thing I wonder about too, I look at these graphical OSDs, is remember a couple years ago, maybe going back about 5 or 10 years ago, they had 3D was supposed to be the thing that was really cool for watching movies. So you're supposed to buy these 3D televisions. and we went to theaters and watched 3D movies, right? And I don't know if you've felt like I did when you went into the theater and you watched the movie. At first, you're like, "Wow, this is really cool. It's 3D."
I
And then
hate
after a
that
while,
crap. I hate that crap.
then after a while, you forget about it, and then you start to realize it's like, my gosh, this is really contrasty. I really can't see most of what's going on in this movie. The dark scenes are really dark, and then you kind of like you moved away from it. But I kind of feel it's the same thing in that if you have a really beautiful OSD, where it's something like, I guess once again DJI has a beautiful OSD. You look at it flying, it's like it's cool, but after a while, you're not really.
The DJI OSD is rendered in your goggles. This is something you have to remember about.
It's rendered. Okay, interesting. So it has. It's cool. I like that. But at the same time, it takes you away. And pretty much, I don't really care too much because I'm really about what's going on outside, and I just look at the gauges as I would like if I was driving a car. It's just kind of like maybe they're more beautiful gauges. It won't really change the way I feel about driving a car, and after a while, I just get used to it anyways. So I don't know if that's. I haven't heard a lot of people saying I really want a graphical OSD.
I'm one of those. Yeah, I'm one of those people. But to be honest, the thing that I most want is the ladders on the artificial horizon, which I think are already implemented. So the rest of it, with all the like your battery voltage, or that can be text as it is at the moment. It doesn't. But the artificial horizon, especially like if you're coming along, go up vertical. I want to know I'm going vertical. So having stuff like that, I think, is cool. And it works well in the vector. I've got the PX, but I've not actually put it in anything yet. But yeah, there are some things that I can see why the vector side or vector graphics would be better.
Mark.
Of course.
Yeah, I think I have also an opinion about graphical OSD. I think there are only two elements I would like to have as a graphical items. That's not even the artificial horizon, because if it stutters or not, I don't care, because it's delayed anyway, slightly delayed. So if it stutters or if it's a smooth movement, doesn't matter for me. You can, Darren, by the way, change the deflection angle of the artificial horizon. You can raise the angle in the CAI to have it still visible even if you are vertical.
It's not just quite right though, because I did extend the angles, and you can extend it too far, and it sort of goes off, and it goes up like that, and then it goes off to the side. It's not.
Yeah.
Where the Vectorbomb's still got the ladders on it, you got a better idea.
Yeah, I know what you mean.
Yeah.
And the second part I would like to have is the stuff for the INAV radar, to have another plane in view and a more precise pointer on the other plane you want to follow, or to have
radar is. I cannot say that this is our in-house project.
Right.
Yeah, I already talked to the developer a few weeks ago.
It kinda almost is, but not really. There is one guy that's really interested in implementing different stuff to the OSD, and it's Olivier. And he's doing that, but still, he's also not part of the INAV radar. And I'm not even sure that right now INAV radar is developed, if they are bringing new features to the table or they just gave up. I really have no idea what's the status of that project right now.
I have talked to the developer of INAV radar, I think back in January or December or so. And as far as I understand him, it was just some kind of side project of him. He just want to test if this is even working. And so he put out the code for the ESP32 modules, and it works. So everything it does is sharing some telemetry data, nothing more, and the rest is done on INAV, as far as I understand that. And
yes, but they originally modified the INAV code to bring the support for this thing.
Okay, so at the moment, I also think that you won't implement any more features there, because it's just working. The telemetry transmission is just working, as far as I see that. I did, I think, 2 flights with it yet when Glenn from the UK visited me, and yeah, it was working to a distance of 3 kilometers or so with these modules. It was absolutely fine. The next interesting thing would be to put it in a 7-inch copter and test it there to chase some planes. Maybe it works. But yeah, I think the rest of the code needs to be done in INAV if there will come some new features.
Guys, this is really the open source project. This is the beauty of the open source project. If anybody is interested in implementing something, he's welcomed to do so. You're welcome.
I'm able to write a calculator.
Maybe that's enough. Maybe that's enough.
How's your C code programming, Mark?
Yeah, as I said, I programmed a calculator about 10 years ago. that's my C programming skill.
The truth is, it's not that hard to make small contributions to the projects. It's really not that hard. You even do not have to be a skilled developer to be able to do so. Because believe me or not, half of the time of coding something is finding the place where the change should be made. So it's really like creative way of using the full text search. Honestly, this is how it works. And then it's like thinking, okay, yeah, maybe instead of +1, I should put +3, and maybe this will help. Oh, it helped, amazing stuff. I'm a developer. So really, it's simple. It's maybe not simple. Programming is even not that hard if you really want to start programming. Maybe many people are afraid of, I'm not a software developer, how should I do it? I was not even the C programmer when I started helping with INAV. So even this argument is not a valid argument. So it's mostly about the will. If you're willing to do it and you think that you can spend some time at least looking at the code and search and find and sometimes search and replace, there's a really big chance that you will be able to make a valuable change to the code base.
So that's a good point, because we've got a lot of people in the group who have advanced degrees in computer science, and a lot of programming. And so occasionally they'll ask us, what is this programmed in? Now we know it's programmed in C, but the question is, I guess, like, they want to help, but they don't know how to help and what to do. And so I think like one example was like a couple months ago, DJI, again, talking about DJI, had those DJI goggles that came out, and this is around Christmas time. I met David Story. I mention his name every single time we're on the channel. I don't know why. And he showed me this sniffer. He had the DJI goggles, and he figured out how to figure out which codes go where from INAV. And
yes, I remember that. Yes, I remember that perfectly.
Yeah. And so he was able to come up with some of the code to help out get this working somewhat. And a lot of the features of DJI goggles working with INAV. So what should someone do if they're a code developer who wants to help out with the INAV project? Should they contact you privately, or?
But why? Why somebody should contact me privately? It's a public open source project.
Okay.
Everybody has access. Everybody has access. There are even pretty decent information how to build INAV locally. It's almost also not very hard. You just on Windows you install Linux and you are ready to go. And then there's one command to build INAV, but still there's a challenge that you have to know what you want to change. If you don't know what you want to change, then kinda it's like, what change what if you don't know what to change. Okay, did that sentence make sense?
Yeah.
Okay.
Sounds good. Well, people know and they do that, and they can contact you once they have a change, and you can put it into the code base on the wiki, and then
like I said, there is developer documentation in the project, and if somebody has really like a question why, for example, the building is not working for him, we have this Telegram Telegram group where those kind of questions are asked pretty on a pretty regular basis, and a lot of people that were building INAV before are willing to help with setting up the environment. And if you really have a question, where can I find some piece of a code, my answer almost always is exactly like this: use full text search. First, locate the name of the CLI variable which is connected to the functionality you're interested in, and then just go from the name of the CLI variable to the actual variables in the code where those variables are used. And if you know anything about the development, then you should be able to find the piece of code that's really doing what you are interested in. This is how I'm working half the time. I just know the name of the variable and I'm just going from there to the actual code.
Oh, okay. Fantastic. And so that's great. We have a way for people to jump in. One thing I wanted to ask you about was I don't know how much, there are a lot of these boards that are coming out now that are, well, occasionally we'll get somebody who'll join the group and they'll have a plane that has twin motors, and each one of them are pulling like 60 amps, and they want, each one has a big 60 amp ESC on them. And these flight controllers aren't really designed to put out that much power per se through the power distribution boards. Like one guy showed he flew a plane with twin motors, and after about the second flight, the thing just fried. It just literally caught on fire because it was an F411 board. And you're talking about the 765, for example. Is this something more along the lines that someone needs a power-hungry plane? This is the right kind of flight controller for it?
I think Paweł has some issues right now.
He froze.
With Skype, yeah, the picture froze.
Do you hear us, Paweł? That's such a hard question. He didn't hear us.
Yeah, he just was.
I saw Paweł.
I will re-add him. So.
Okay, that sounds good. How are you guys doing, Darren? There's no graphics in the background today.
No, I have issues with sunlight coming through this window. So if I put graphics up, it just constantly changes the color depth on the green screen, so I have to constantly edit it. So I'll get some blinds and then I can get the green screen working again. Nice consistent lighting.
At least you still have sunlight, because it's getting dark here in Germany.
yeah, it's going down, but it's still quite bright outside.
Fantastic. What have you guys been building since you've had all this downtime?
Well, I've got my F1 wing ready to go again. That's got the air beam motor in it now, 6.5 by 6.5 prop.
Be running 6S. It's fully laminated, so that's good to go. My S800 is nearly ready. Just waiting on a video antenna for that, and then I can laminate the final parts, and that's good to go. I've started on my mini Talon finally.
Oh my gosh!
Which that's going to get that F722PX. Powell's back.
Powell's back, yeah.
Wait, we can't hear it now.
Now your microphone is not working right now.
Oh, okay, now better.
Here we go.
Yeah, my laptop decided it will just go. And I was able to experience the blue screen of that, something that's not happening very often with Windows 10 nowadays. But, for example, it's happening from time to time. So, what were we talking about?
Well, the 765 board, somebody who needs a power-hungry plane, like, for example, Darren was just telling us he's building a mini Talon. So that thing, how many amps is that going to pull?
Oh no, that won't need that. It's only 40 amps. It's tiny. But yeah, I mean, like you were saying, that like a twin motor plane with two 80 amp ESCs on it, that would be something for that 765.
That 765 should handle it, okay, pal?
765, it's mostly about the number of servos and the total amperage on the 5 volts voltage stabilizer. It's not really about the max current for the motors. I doubt that anybody could fry those short, thick traces of the PCB. The main argument for the 765 is the number of servos this thing has, because it has like 10 or something.
Yeah.
Or
The funny thing on the 765 is it is rated for an 8 amp servo output, but the actual BEC has a maximum rated 12 amp of current capacity. They just limited the specs because the traces are too thin to handle the 12 amp continuously.
That and they are limited because I spoke with the guy from Matek, Samson. Probably you've heard about the guy once or twice. Yeah, he told me that yes, the hardware itself can run on those 12 amp mode, but they have to limit it because there are no chokes big enough, as much as small enough to be able to put on this board, because the choke that would be able to work with 12 amps is like twice as big as the 8 amp, and they just would not fit it in there.
So the current sensor, by the way, has a limit of, I think, 132 or 136 amps. So I think even for a very powerful twin motor plane, it should be enough.
And this is where it really cuts out. You can run more, but you will not be able to measure more.
Yeah.
Interesting. No, because I'll be looking for a flight controller for my fun jet at some point, and that's going to be pulling about 200 amps. So I'm thinking of using the X-Class board for that, because I think that's a bit more through the current sensor, but it'd be fun.
Maybe, but it's really the chance that you will fry the PCBs rather not that big, because they are really like big traces of the copper over there.
Paweł, by the way, I have a question at this point. The current sensor, actually, it's just a voltage sensor over the shunt resistor, right?
Depends.
Okay, it depends. Let's say on the Matek boards. As far as I understand,
this is the shunt resistor of 0.5 milliohm, and there is a separate chip that measures the voltage drop over the shunt resistor and converts the voltage difference to analog output. Yes.
So, and how often in INAV is the voltage actually measured? Is it one time per loop? Do you know that?
No. I would like to know the answer for that question.
Because the point why I'm asking is,
I can check it if you really want. If you really want to, I can check it.
Yeah, it would be interesting because
it's only a code after all.
Because I asked that because on my Dart 250 that is pulling very, very low current, so it's about 1.6 amps or so when I'm cruising. I had the issue especially on 2S, that the current sensor was jumping all over the place all the time. On higher currents, it was stable. But then I added a capacitor between the ESC and the motor to have a more continuous current flow and not the spikes from the PWM control, voltage control of the ESC. And then the current sensor was absolutely stable. So I'm just curious how often the loop time is. So it's
50 hertz.
It's 60 hertz. Okay, that makes
50.
sense. 50.
50 hertz.
Okay, that makes sense, because then sometimes if the PWM signal of the ESC is on, it shows the on current, and then it pulls at a moment when the PWM is off.
There is still a question of how often the ENA the current measurement chipset measures the voltage drop. No bloody idea, mate.
Okay.
Plus, probably there is a capacitance on the output of the current sensor. So either way, the output that goes into the analog digital converter of the flight controller is already smoothed out. But please do remember that all those measurements with the shunt resistor are, let's say, not the most precise devices ever.
Yeah, of course. But I managed to handle it. I tested it with 50% throttle and I think 2.1 amps or so, and also at 1.5 amps. And roundabout, it's precise to 10 milliamps right now. So the shunt resistor that INAV measures compared to my external measurement device.
Also, please remember that especially on the very low currents, there is always some kind of the noise on the input to the analog digital converter.
Yeah, of course.
Those things, there is always some electrical noise running, even if the ground is not really connected very close to the places. This can introduce some error, but we all have to remember we are using a hobby grade components.
Yeah, of course.
Those are the cheapest crap on the market.
Even on Maytag boards.
Yeah, but even still, think about the gyros we are using and the accelerometers you are using. At least for a few times, I've heard questions about, but you know, those military airplanes can have the inertial navigation and go like hundreds of kilometers in one direction, relying only on the gyroscopes. Dobrze, już niedługo będę kończył.
Yeah, but their gyroscope systems cost more than a car.
Exactly. We are using sensors that are designed for the smartphones.
Yes.
Our sensors are for the smartphones. Let's not really expect too much of the piece of the electronic that costs $1.
Actually, just thinking about that, the electronics you've got on your 7-inch that you're using that's knocking out the horizon drift, roughly how much is that component compared to what's already on the boards?
Almost nothing.
That's it's still a cheap component. We just need Maytag to stick it on the boards.
Everything in our hobby is extremely cheap. Some time ago, I was contacted by the guy that is an owner of the company that is doing some high-grade gimbal controllers, really like the gimbals. The gimbals that are cost like a few €1,000 a piece, not even the stuff that they are selling. And he gets some advices that, for this maybe the sensitivity of the gyros and accelerometer is too low, because we were playing with those available on the market and they were just drifting all the time. And but they were really like building a hardware that was costing $1,000s for a piece, even dozens of thousands, because then I checked how much a single board that he says is good, a single board, the gyro and the accelerometer, the cheapest version, $500.
Wow.
So what are we really comparing? The cheapest board, $500.
Has a question.
500.
What I was getting at is on the multi-rotor that you're testing, where you've got the Bosch chip. Comparatively to the gyros and everything, would it, if Maytag were to put that on the board, is that something that's potentially viable if it works?
Yes, if it proves that, yes, and the code supporting this will be better than is right now, then yes, but still, please do remember that one of the limitations that we have right now for the flight controller is the size. There is not much available space on the 36 by 36 board for the multi-rotors, or something slightly bigger for the aeroplanes. It's really hard to put everything that's theoretically possible to put over there and still keep the relatively small footprint. Adding the B&O 055 to a board, it's a few bucks extra, but the chance that it will be able to fit current size of the flight controllers is rather slim pickings. For example, why? Because it has the compass, and so it cannot be too close to the power traces, to the wires, because that would make everything go. So you would have, probably the best idea is to put it on the cable somewhere, but still, it's not that simple. We are limited by the physics, and a lot of people forget that we are limited by the physics.
Yep, no, that makes sense.
That's A question I had for Mark was, you were talking about that capacitor. What microfarad was that?
It's 1000 microfarad low ESR. I just ordered a bunch of them to put on my planes to eliminate video noise, and it's pretty big, but it seems to work. It seems to work fine. But you can also use smaller ones, I think.
If you want to eliminate the noise, either use a coax wire or twist the signal with the ground.
Yeah. That's what I did on my new 5-inch copter too, because the noise was really heavy, and I already put a cap on it. Still noise. What I did is I twisted the cables very strongly, and I also connected them to the camera power to the VTX instead of the flight controller. That also lowered the noise, because the VTX power also has smaller traces from the flight controller, so it's not transferring that much noise anyway, and it also has additional filtering.
Yeah, exactly. Yes.
That's good to hear. Fantastic. Well, guys, I think that we've had. Is there any secrets before we let you go, pal? Anything that any surprises for us for INAV? Anything you want to let us know?
No, not really. Okay. Not really. Yes.
Fantastic.
Maybe, who knows? Maybe. But
well,
how much money have you got?
Surprises I cannot tell you, right?
Yeah. Okay. I mean, I can tell you this much: everybody who gets involved with a group, who gets flying the plane. I mean, they are so excited by the time what INAV can do. I know this is the cheapest stuff we can put in the air. And trust me, sometimes when I'm standing there thinking like, oh, my plane is flying over a bunch of houses right now a mile away. And by the way, I'm trusting this to the cheapest hardware I could possibly buy coming from China. But I'm fine with this. You know, I know it's amazing what you guys can do. We really do owe you a big debt of gratitude for everything that you've done for INAV, and not only you, but all the developers. Yeah,
I can also say thank you.
I have a great example just from yesterday. I was doing a long-range flight with my 250G, and I had some video issues, but that's another topic. And then I was on the way back with return to home, 5 kilometers away, and then I just posted a picture on Facebook and was chatting and writing comments, and I wrote, yeah, I'm on the way back home now, and I need to check that. And someone was writing, what the hell? You are flying and you're writing Facebook posts? I said, yeah, I trust my build, I trust INAV, and I trust my hardware, so it's totally fine for me. It works perfectly.
You should not trust that much. No. Possible crap and the free software. No, this is the.
I have to say, after if I flew a few hours with my planes in cruise mode, in navigation mode, in return to home, and everything is tuned fine, I have no worries trusting it to coming back.
Well, I had no worries today before my flying wing decided to fly away from it. So, you know, those things just happening from time to time.
So what happened? Tell us about it.
It's a build that I made it back in February because of this. Dobrze, już będę powoli. Już parę minutek I już koniec. Yeah, my family would like me to finish already. But okay, we are slowly getting there. This the last story.
So put her on.
Okay, so it was the build. I upgraded the INAV. I put everything. The hardware was tested. It was flying before the software was tested, but not really tested because it was development version of the INAV of latest changes. Tested everything on the bench. Tested everything on the field over there. Radio working, servos moving, motor spinning, and I threw this thing into the air. And I only saw it was going like half a kilometer later it crashed into the ground. I had no control. Why? Absolutely no idea why. In the beginning it was idea maybe the CPU hang because something there. But then at home I revised the OSD, DVR, and it was fine. It was not the situation. The receiver did not fail safe. Nothing really was hanging on the flight controller side. Everything seems to be working, but I had no control over the thing. And at the peak of this, in the final moment, it crashed into the air with the speed of 132 kilometers per hour. Surprisingly, only lost the winglets and the RX antenna. Everything else seems to be in place. So, why? No idea. Maybe a radio glitch. Maybe something else. Probably radio glitch, and the receiver was not getting any data from the transmitter. Although I was using this hardware on the multiple occasions, there were really never any problems. And I know from the OSD that the receiver, the flight controller, switched to return to home 200 milliseconds before hitting the ground.
We just blame the coronavirus or 5G.
Why it happened, I have absolutely no idea. I know the transmitter is fine, the radio is fine, the receiver was working before. I will probably have to just repair the airplane, find a new antenna, and then without much trust in the build, try to play with it again. But when, who knows? When the China is rather not an option for buying stuff right now.
Okay, great.
You know, it's kind of the thing that you keep in mind is like a lot of people, when they get in the group, they, you know, this is something that's kind of above them. And kind of like what you're saying too, it's a common theme, which is you weren't really a C coder before you showed up here and started working on it, but you applied yourself. And that's kind of the theme of the group has been is, if you want to do this, you can do it. We'll help you out, but you have to apply yourself and you got to make it happen.
Yes, you have to want to do it.
Yes.
Because nobody else will do it for you. Nobody will come to your house and build your quad or airplane for you.
That's exactly right. And so what it's done is, by doing this, you've actually helped a lot of people out, you and the rest of the group that developed this, because what you've done is you've empowered people to be able to do something, to set a goal, to find something that's difficult, to ask questions. And that's something, the group is like 98% males, you know, and we're not really super good about asking for help and asking for directions.
99% of the males, I know, because I have analytics of the INAV.
Yeah.
I know the gender of the users of the INAV.
Yeah, we're mostly guys. We don't like to ask for help. We don't like to ask for directions. But
Definitely.
if you want to be able to fly a plane, you have to ask for help, ask for directions. Also, admit when you failed. And it's kind of interesting to hear, like, even the guy who develops the stuff crashes occasionally. So it's, you know, that's kind of what it's the good, the bad, and the ugly. That's it. I think we're done for today. Paweł, thank you so much. We really appreciate it.
Thank you very much for the invitation.
Yeah, this is great. We have to do this again, and I hope you get out, do some more flying here in the next couple of weeks.
Starting from tomorrow, I will be legally allowed to do a recreational stuff outside of my house. So maybe finally.
Yes.
Sounds good.
Fantastic.
3 weeks.
That's it. Well, enjoy your dinner. Tell your daughter we're very sorry for keeping you away. They get their dad back for the rest of the night.
Yeah, it's mostly about the wife, you know.
Go upstairs and tell your dad to get off the phone.
She has a limit of 90 minutes. After 90 minutes, she's like, oh, Paweł, you should come down from the... Yeah.
Fantastic. Well, thanks again. And it was a total pleasure.
Much.
We really enjoyed this.
Yeah, thank you.
Thank you, guys. Bye-bye.
Okay.
Bye.
Thank you. Bye-bye.
Okay, stream is offline now.